simplifying rational expressions. So I'm going to start with a very simple example. Right? If I had something like this, 2x over x squared, I can simplify this because I have something in the numerator and denominator that can cancel. So in this case, what I have is an x, right? I have 2x, another way of looking at this, and x times x. So I can cancel this factor, I can cancel this x, which gives me 2 over x. I have a question. Can you always cancel out x over x?
Yeah.
I mean, if I just gave you this, x over x, the reason I can cancel this is because it equals 1, right? Is that always true?
Yes.
Does x over x always
that's
equal 1?
because, whatever
It's not true, that's why I'm
out,
asking you.
the
0
root
times 0 times
is.
Yeah, what if x was 0? Does 0 over 0 equal 1? No. So I actually can't always do this and say that this is the same thing as this. Okay. Now with this problem, x also can't be 0 because I can't have 0 in my denominator. And so what we do is we say the excluded value of x does not equal 0. And in this problem, I'm saying that because I can't have a denominator that's 0, and I can't cancel out a 0 over 0. So when you're simplifying rational expressions, you will just about always have this little thing called an excluded value. This is true as long as x does not equal 0. Another way that this is sometimes phrased is finding the domain of this expression. The domain of this expression is all the real numbers except when x is 0. So it's x does not equal 0. This is our domain for that function. Remember, the domain is all the possible x values. And the range is all the possible y values. That's right, but we're not going to talk about that. So what if I had something like this? X plus 3 times x plus 4 over x plus 3 times x plus 2. So the first thing I want to look at, these are my factors, right? X plus 3 times x plus 4 and x plus 3 times x plus 2. Because I have to remember that rule about canceling factors, not terms. So, for example, I can't just cancel the x's here. And I can't just cancel the 3's. I would have to cancel this whole thing with this whole thing, which is what I would do for this problem. I would cancel out the x plus 3, but when is that not allowed?
If it's a plus. Wait, no.
If x was
x minus 3 or something.
if x was negative 3, then I actually couldn't cancel that out because then it doesn't equal 1. Then I'm canceling 0 over 0, which isn't really allowed. So I'm left with x plus 4 over x plus 2. But I have to say, x does not equal 3. I mean, negative 3. Because negative 3 is what would have made this 0.
Oh, I get it.
X could also not equal negative 2, because negative 2 is going to make this denominator 0. Okay, and that's our excluded value for this simplified rational expression. Or those are our excluded values. Incision on the denominator. Okay, but usually, typically when you see problems like this, they're not going to be nice and pretty like that. Right? They're going to usually look more like this. 2 2x squared plus 13x plus 20 over 2x squared plus 17x. So as this is, the only way I could cancel is if this entire thing was the same as this entire thing. Because I have terms here. So I only have one factor, and that's the whole thing. But I can factor this. We've now learned how to factor things like this. So that's where you're going to start. I'm going to look at the top, 2x squared plus 13x plus 20, and I'm going to try to factor the top. So I'm trying to think of factors of 40 that add up to to 13. 40 would be like 8 and 5, right? So this would be 2x squared plus 8x plus 5x plus 20. So I'm going to have to do Gary's terrific trick just to factor this. Pull out a 2x, and I have x plus 4, plus, pull out a 5, and I have x plus 4. And so in the numerator, my factors are 2x plus 5 times x plus 4. Now I've got to do the same thing with my denominator. I need factors of 60 that add up to 17. Factors of 60 that add up to 17. Right, because 2 times 30 is 60. What'd you say? 5 and 12. Beautiful. So I'll rewrite this using 5 and 12. Did I do that right? Okay. Pull out 2x from the first two terms, and I have x plus 6. Pull out 5 from the second two. So my factors in the bottom, I'm kind of skipping a step, but just by just writing it over here, right? So my factors here come out to be those. Beautiful. Now I can cancel my 2x plus 5. Because now I have a factor that cancels in the top and the bottom. So now I have x plus 4 divided by x plus 6. As long as x does not equal what?
0.
Negative 6.
5 halves. Because that's what would make this expression 0. Now, if you're not sure about doing these in your head, just write it out, right? 2x plus 5 equals 0. And then just solve it. Subtract 5 from both sides. 2x equals negative 5. Divide both sides by 2. So x equals negative 5 halves. And you can save yourself a lot of pain just by writing those out every time, rather than trying to do them in your head. Anyway, x does not equal negative 5 halves or negative 6. Because that would make the denominator 0 at some point. Right? And that's our answer.
Mandatory to do. The x does not equal.
It is.
For on the prep thing, when it said like, when we said x equals 5, would you have to put like, if it was...
Yeah, I think you would really impress them if you put that on there. That would
so
be
you
my
put,
guess.
like x does not equal, like, whatever.
Yeah. Because this is, technically this is all part of the same thing, simplifying. So when you see on a placement test a problem like this, right, and they want you to simplify it, they're trying to see if you know, number 1, factoring, right? Just can you factor these? And then number 2, they're trying to see if you know excluded values. And they're testing those two things with one question. Because if you know how to factor these, you can factor them and cancel. But if you haven't learned about excluded values, you would just get x plus 4 over x plus 6. And actually, x plus 4 over x plus 6 is fine. You wouldn't necessarily have to write that x does not equal negative 6 if they didn't ask you for the domain of the function, because it's still obvious here that this is negative. I mean, that this would make that 0. But because you canceled the 2x plus 5's out, this one has to be there. You have to say x does not equal negative 5 halves. Because this is not the same thing as this if x is negative 5 halves. And we could actually prove that to ourselves. We could make x be negative 5 halves and see what happens here and see what happens here. But I don't want to do that. So just trust me. If you plug negative 5 halves into this equation, you're going to get 0 over 0. But if you plug it into this equation, you're going to get negative 5 halves plus 8 halves, which is, what, like 3 halves, over negative 5 halves plus 12 halves, which is like, I'm losing track of myself here. Negative 5 plus 12, is that 7? So whatever that is. So you get an actual number. And so in that case, that number is not equal to 0 over 0. So that's kind of the concept behind why you have to say this. This expression is not equal to this expression if x is negative 5 halves. You will not get the same thing if you plug those two in. Yeah?
Like, so at any point in the equation, if you have 0 over 0, the whole equation is completely.
Well, watch. Let me do a simpler example, just because this one will be kind of miserable. Well, let's just do this. So what if I just had, what was that first one that we did? So what if I had like x squared plus 7x plus 12 over x squared plus 5x plus 6. Okay, this is the first problem that we did, but it's just FOILed. So it's not factored. And so we decided here, if we factored this, this would be x plus 3 plus times x plus 4 over x plus 3 times x plus 2. So we're saying this is equal to this, and then this is equal to x plus 4 over x plus 2. Okay, but I'm going to prove to you that this does not equal this by putting negative 3 in here. So I'm going to say x is negative 3. When x is negative 3, this would be negative 3 plus 4 over negative 3 plus 2, which is 1 over negative 1, which is just negative 1. But now, let's plug negative 3 into this one. We'd have 9, because that's negative 3 squared, minus 21, because that's 7 times negative 3, plus 12, over 9 again, minus 15, because that's 5 times negative 3, plus 6. So 9 minus 21 would be negative 12, plus 12, that would be 0. 9 minus 15, that would be negative 6, plus 6. I got 0 over 0. But wait a second. I got negative 1 here. I thought these were supposed to be equal. Not if x equals negative 3. So that's why we're saying this, right? Any other number, if I plug it in here, and I plug it in here, I will get the same thing. So let me prove that to you too. Let's pick a number like 2. So if I plug 2 in here, I get 2 plus 4 over 2 plus 2, which is 6 over 4. Right? Now let's plug 2 in here. I would have 4 plus 7 times 2 is 14, plus 12, over 4 plus 10 plus 6. I'm doing this right. 4 plus 14 is 18, plus 12 is 30. 4 plus plus 10 is 14 plus 6 is 20. 30 over 20 is equal to 3 halves. Wait, I thought I was going to get the same thing that I got down there.
That's the small.
It is the same thing, yeah. 6/4 is also 3 halves. So any number that you plug into this, you will get the same thing as if you plugged it into this. This is a simplified version of this expression. Now, if I were graphing something like this, I would much rather plug into this than into this. Wouldn't you? I mean, it's a lot easier to just add 4 and add 2 than it is to square and times 7 and add 12. And so that's why we do this, is to get a simplified version of a complex expression. But in doing it, we are simplifying something out that does sort of affect our answer. Okay. That's definitely more than you have to know about these. But I think it's good to see, like, why are we saying x doesn't equal -3? It's because this won't equal this when x is -3. All right. All right. One last little thing. Can you simplify this? You can. But not as it is. Because this is x minus 2, and this is 2 minus x. But there is a trick if you get something like this. You can actually pull a -1 out. So watch this. X minus 2 I'm not going to change. But I'm going to change this by multiplying by -1. So in other words, I'm factoring out a -1. What I would have left inside my parentheses is -2 plus x. Right? Because -1 times 2 times -2 is +2. And -1 times x is -x. So we have x minus 2 over -1 times, this could be written as x minus 2. Now I can cancel those out. And so this expression would be 1 over -1, or just -1, as long as x does not equal 2. Because I canceled out x minus 2.
So wait, is it written like x equals -1 if...
So it's not x equals -1. This expression, this equals -1. This whole thing, x minus 2
Okay,
over 2
yeah,
minus x,
simplify.
that is -1 when we simplify it. Unless x was equal to 2. And we could prove that to ourselves. Pick a number other than 2 to plug into this expression. So like 3, that would be 3 minus 2 over 2 minus 3, which would be 1 over -1, which would be -1. Right? So this is equal to -1, unless we picked 2 for x. Because then we'd have 0 over 0. Alright. Okay, so that's a lot. Let's do an example or two, just to solidify this. You're going to see a lot of differences of squares with these. So like x squared minus 36, it's fairly common to see a difference of squares when simplifying a rational expression. So the instructions that you'll see here is something like simplify. And it might say state excluded value. Or it might say state the domain of the function. And technically these are slightly different, but really they want you to do the same thing. Okay, so we're going to simplify this. Remember, we can't just go canceling 6's and canceling x's. We have to cancel an entire factor. So let's factor the top. X squared minus 36 is the same thing as x plus 6 x minus 6 over 6 minus x. Uh-oh. There's nothing we can factor or cancel. Because we have x minus 6 and we have 6 minus x. Those are different. But when you see that, remember, x plus 6, x minus 6 is not going to change. This is the same thing as negative 1 times x minus 6. Because negative 1 times x gives us the negative x, and negative 1 times negative 6 gives us the positive 6. Now I can cancel this out. And I would just have negative x plus 6 as long as x does not equal 6. Because I canceled out x minus 6, and 6 minus 6 will equal 0. So we're combining everything that we've been practicing. We're combining factoring, finding the zeros, right, as well as this new trick of simplifying these expressions. All of that stuff is involved with these types of problems.
Why is it, never mind.
Okay, let's do one more example. Let's say I gave you x plus 3 over x squared minus x minus 12. Same instruction. Can the top be factored? No, it's already factored, right? So I'm not going to do anything to the top. But on the bottom, I could factor this. I would factor it as x minus 4 and x plus 3. Right? Just a quick check in my head. X times x is x squared. X times 3 is 3x. Minus 4x is negative x. And negative 4 times positive 3 is negative 12. I would always take the time to just check your factoring. Although in these it's sort of going to check itself. The x plus 3's are going to cancel. So we just have 1 left up top over x minus 4 as long as x does not equal negative 3. And if they asked you for the domain, you would also want to say x does not equal 4.
What does domain mean?
Domain means what can x be in a function like this. Okay. And x can't be 4 because we can't have 0 in a denominator. So domain is what can x be is what they're asking me. Okay, I think it's time to practice. For you guys to practice.